Welcome to EMO 2023. We're here now on the ANCA stand. And what a big stand it is. They're showing some fantastic machinery off here. There's quite a lot of machines you might have seen before, but they've got two brand new machines as of EMO 2023 to show you. There's one we're going to be unveiling personally. Myself and Santosh over there are going to be unveiling it personally just for your eyes only. Everyone's here enjoying the hospitality on the stand, Martin, and hopefully enjoying the technology. What is special about ANCA technology that people should, and they know the brand, but what is special about ANCA technology you're trying to show here on the stand today?
Hey Rowan, welcome first and foremost to our ANCA stand. As you can see, buzzing with excitement, buzzing with innovations that ANCA is bringing to the market. We're very happy to be back at EMO. It's been 4 long years.
Yeah. And you've come a long way.
Well, you know, ANCA is based in Australia, but you know, we value our customers in Europe, and so happy that after 2019 we're back at EMO. Can I say I was born in Hanover, so I feel, of course,
back home, right?
Back home, especially welcome in Hanover.
Brilliant.
Now we are unveiling 2 brand new machines today here, and can I say the key is what we call the Ultra experience, an experience you can only have on an ANCA machine. It's all around pushing the limits of physics in machine tools as far as humanly possible. And those innovations we are introducing today here to our audience, to our customers, to our partners, is on the one hand a Micro X machine that Santosh will in a moment unveil for you.
Let's not give too much away, Martin.
Sorry, didn't say that. Please forget the last 30 seconds. And on the other hand, the FX7 Ultra machine. Santosh will go through the technology behind it, but can I just say nanometer technology on all the axes, right?
And that's the Ultra experience.
And that's the Ultra experience, among other things. You know, just for those out there who are not familiar with nano, a nanometer is roughly how much your fingernail grows in a second. So we are looking at a very fine resolution on all the axes. And so, you know, until further ado, I'd hand you over to Santosh to the unveiling of our Micro X, an impressive machine. Our team has done a fantastic, superb work, and you've heard the buzz earlier today when people discovered it first. So very happy for your viewers to be here unveiling the machine.
Thank you very much, Martin. I'm sure the viewers are so excited to see what the machine is going to be like. We'll see you in a little bit, Martin. Thank you. And it's really important to make sure your grind on your cutting tool is absolutely accurate, whether you do micro machining or standard machining. So the grinding machine is where the machining process starts. We're pushing the limits of physics apparently with this machine. So I'm going to unveil the machine with Santosh. We'll introduce him in just a second. Let's get the machine unveiled. Wow. Santosh. What a machine. Get in there, cameraman. Let's have a look. So this is Santosh. This is your product, right?
Yep.
What are we looking at?
Well, this is a machine specially designed to grind micro tools. Now, what do I mean by micro? Those tools can be all the way down to 50 microns or diameter 0.05. And these are sometimes called as nano and sometimes called as micro tools. And you need a specialized machine to grind these tools within a range. And our own customers have been asking the question, when am I going to get a machine which is designed exclusively for that application? And here is your machine. It's a 6-axis machine, and we have all heard about the nanometer control and the Ultra experience. This is taking that to another level. And in fact, we have also introduced the ANCA machine intelligence. There are so many things the user doesn't see in this machine. But if you're looking for a machine which is purely for your micro tool applications, then this is your machine. Volume production, day in and out, and it has all the process capabilities in the machine to give you volume production with the accuracy and the tolerances what you want.
That is fantastic. So being a good micro machining, a machine capable of grinding these micro machining tools, what is the demand for micro machining tooling? Why is there a demand for this kind of cutting tool nowadays?
There are many industries which use micro tools. In simple words, talk from your classic watch design, all the watch and jewelry industry, plus the 3C market, where the chip industry, where the you also have the what's called as the Internet of Things, okay? And plus use, maybe not aerospace much, but mainly in the electronics, watch industry, to an extent in the camera lens industry as well. But these tools are not something which are very common, and that's why they are very special. It's difficult to make. To put a foot in that is challenging. We want to make our users' experience easier. We take over all those responsibilities, and then we make it happen.
Absolutely. I guess as machine tools get more accurate,
Yes.
then you can start to use these micro machining cutting tools as well. You need a good, accurate machine tool to be able to use these, don't you?
Well, I think it's the other way around. Our customers and our needs are changing. What they are telling me is that give me a tool which can last forever, which is impossible. How close can we get? And that is where we are heading. Absolutely. So those demands are changing. High performance, when I say high performance, a tool is used in a machining environment. If that tool can last 20 or 30% better than any other tools or made on any other machines in our competition, then we are actually ahead.
Absolutely. And it's really hard to make these very fine cutting tools.
Yes.
You've actually had to bring an electron scanning, a 3D scanning microscope, if that's correct, if that's right,
Absolutely right.
to be able to measure the tools that you make, because otherwise you don't know if you're grinding them correctly. So what are you showing us here, Santosh?
So what's happening here is, as you already know, that we have the nanometer control. Now, an optical microscope cannot necessarily see anything to do with your variation in your ball profile or your surface finish. We had to work with Hitachi, for example, and ask them, look, how can we measure these tools? And they gave us this desktop SEM, which is using a completely different technology.
SEM being scanning electron microscope.
Electron microscope, and not an optical microscope, because the optical has its own limitations. Here, what we're doing is basically using is scanning electrons. Basically, electrons are thrown at the part, and the reflection. And you can see here, this is basically a diameter 0.3, 0.3.
And that's so diameter 0.3 across between the two flutes.
Two flutes. And the features of these tools are less than 10 microns.
So this is a 10 micron. This is called the gash or the chisel point.
The chisel point is 10.1 microns on this instance.
Wow.
And as you go down, as you said, this machine is able to grind 0.05. So you can imagine the features are much more lesser, probably a fraction of that, perhaps even in 2-3 microns on this SEM microscope. So without this, without seeing the problems, we can't fix it. That's my point. Yeah.
If you can't measure it, you can't make it.
You can't make it. That's right.
So you need a scanning electron microscope. And if we go over a little bit closer, we can see even here, this is a close-up of the component, and you see the chisel as the two grinds of the primary flank meet.
That's correct.
What did you find here? This is very difficult to achieve.
As I said, this is 10 microns, and we're expecting that to be a straight line.
That chisel point needs to be a straight line for as you mentioned, tool wear, which is very important.
Exactly, number one. And number two is you can see the grinding pattern. You can see the grinding lines are consistent across the face. This is very important. And that's only the result of our ultra experience and the nanometer control.
And this actually proves what you're saying about the accuracy of the machine tool, of the grinding tool. This actually proves it. Rather than just saying this can achieve those tolerances, that straight chisel line on a 300 micron, a 0.3 millimeter end mill, that proves the accuracy of the ANCA Ultra line.
And I think I've only shared about 5% of what I can.
There's a lot to talk about, right?
Okay, so we'll be the whole day here, but thank you for having me.
Perfect. So thank you very much, Santosh. We'll see you soon, okay? So it's absolutely fascinating, the quality of the ANCA machines that they're showing off here, especially the new machinery. Now, being a new machine, they're moving into micro machining. It's definitely a new industry. Maybe some cutting tool manufacturers out there aren't quite moving into micro machining, but I've got Darren here to talk about another brand new machine. This is more kind of for the general cutting tool manufacturing market, Darren.
It is. It's look, the machine's been evolved, and we've taken on the Ultra package as similar to the Micro X over there. So with the Ultra package, what it's enabled us to do is be able to grind a wider range of tools. So from diameter 20 down to 0.1 diameter, and that we can do with ball nose, corner radius tools, barrel shaped ball nose, profile tools.
Those are some quite complicated cutting tools, aren't they?
Yeah, they are, and some of the big problem we used to have, or there's out there in the market, is there's transition marks and surface finish issues and just waviness over profiles. But with the Ultra experience or the Ultra package, it eliminates those because of the 1 nanometer control.
Absolutely. And how can you achieve that 1 nanometer control? Now, we've got some explanation of kind of the Ultra experience on the board here. And I've heard kind of some people have been talking about using ANCA controls, ANCA drives, ANCA amplifiers, whereas others might be using kind of third parties. Why is that important to use your own controls and your own amplifiers?
Well, really what it does, it allows us to control everything that we do. So from the machine base through to our software, through to the mechanical part of the machine, as well as the drives and motors, we can control everything. So what that's enabled us to do is to develop our software and our drives and controls even further to be able to get that 1 nanometer resolution, which is 1/1,000,000th of a millimeter, which is
it's tiny, absolutely tiny.
Yeah, so it really enables that smooth transition and eliminates those errors that used to be seen in cutting tools.
Yeah, absolutely. And you're kind of squeezing the best out of, and Martin was saying you're kind of pushing the laws you're pushing physics of machine tools right down to the absolute minimum in the mechanical design and the electronic control. Let's talk a little bit about the more ergonomic side of the machine, which is kind of, you've got some automation which helps subcontractors. Also, I saw it changing a wheel pack over. These are kind of niceties to have, as well as the accuracy for a subcontractor or even a kind of a production cutting tool manufacturer.
Yeah, absolutely. So the FX platform is quite a small footprint. It's actually a compact footprint, one of the smallest on the market. And what we have inside is a Fanuc robot, which actually does our tool change as well as the wheel change as well. So we use the same robot to be able to do both, and it's all confined within the machine. So here you'll see that we've got a wheel change happening. Actually, it's doing the laser measurement. Just going back to that, sorry. What we do here is measure each tool individually and can make sure that we get consistency across the batch. So from your first tool through to your last tool, we guarantee plus or minus 25 or 2.5 microns.
Yeah. So that's absolutely important if you're running this overnight and you want to make sure you don't make a long line of scrap end mills. You need to make sure that every single one's right within process inspection. Now, when it comes to a machine like this, that is obviously, you've had a lot of engineering time and process and development put into this. Why would a subcontractor choose a super accurate grinding machine like this versus kind of a more general machine, a more general machine that can make kind of standard end mills? Why would they go for something that can do this range of diameters and these complexities in the form?
Well, I think it comes back to market needs and industry needs. As we go further in the industry, tolerances become a lot tighter, expectations on the finished product become a lot tighter. So if we look at defence or medical or things like that, the cutting tools we need to be a lot more accurate. So by using that, once again, the Ultra package, the nanometer control, it enables us to get those tolerances and the forms exactly how it needs to be, as opposed to being close, I guess.
But nowadays, surely, is it possible to produce a complex tool even without the absolute fine control that you need from this kind of machine?
Yeah, look, it is. The software remains the same, or we've added some software to the Ultra package. The software remains the same, so we can still grind those complex tools with our standard machine, but the Ultra package just enables us to grind high quality cutting tools. So every time we grind a tool on the Ultra, we get that high quality cutting tool.
So it's more about the reliability of the process, knowing that you can get those cutting tools right every single time and hopefully run overnight with your automation.
Absolutely, absolutely.
Yeah, let's move on. Let's move on. So 2 brand new machines from ANCA. If you were here at EMO, you could come and see them, but the second best thing is to see the videos coming on the MTDCNC channel. We're going to be filming here tomorrow, so you'll be seeing those videos coming soon on the new machinery. You've also got, you've also got Honey, I Shrunk the Tool. What's this about, Darren?
Well, it's a competition around the Ultra and moving into the micro tool market. So we've got a replica of the Ant there with the antenna is the same in scale with the cutting tool itself. And basically it's a competition that if you scan the barcode, oh look at that, if you scan the barcode down there and follow the instructions, submit your photo and you're in the running to win a $1,000 voucher. So great competition.
$1,000 voucher. I can't wait for my voucher in the post then. It was quite fun being an Ant at that point. I love it. Thank you very much, Darren.
No worries, thank you, Tom.
Brilliant. Thank you for watching the MTDCNC stream here at ANCA Grinders.